All right, everyone. Welcome to the first lesson during our shutout from the school normal schedule, I guess. I'm going to start off with chapter 7.1 and 7.2. Even if you have covered it over the past couple of weeks, because I sort of posted it as a, I guess, busy work for you. Then there'll be review. If you haven't done anything I suggested that you do, then this is going to be fresh, but either way, you're going to be responsible for it. Before we begin, let's get some logistics out of the way. Please follow the instructions very carefully on Google Classroom. Things might change. I'll give you more information of what you need to do, maybe some forms you might want to try, some formative quizzes, some worksheets, whatever. It's all going to be there. Also, every Friday at 11 a.m., I'm going to have an office hour through Google Meets. What I will do is post a link on the Google Classroom of where you can find me through Google Meets. And I'll post it maybe a couple minutes before the actual hour starts. So let's say like 10:55, I'll post a link. You can check it, click it, join the Google Classroom, join the Google Meets meeting, and ask me questions there. But please follow the instructions on your mic and camera being off so that, number one, you don't feel invaded by people seeing you, and also that you don't interrupt other people or myself as I'm trying to answer a question. Also, from now on, when you watch a video, you may want to have a paper and pencil handy and copy things down with me so you don't have to keep watching this video again and again and again in the future. You have these notes in front of you. I think watching these videos again and again is going to be a waste of your time, but that's your choice, I guess. It's my recommendation. Another thing you would want is a calculator and a periodic table, because as you might have guessed, stoichiometry really heavily uses molar mass. And you can only get that from the periodic table. All right, let's get to it. So 7.1, 7.2, anything that involves stoichiometry, you will find that mass alone is insufficient. Moles are absolutely necessary if you want to calculate the amount of reactant or product in a reaction. And so you are going to use mole ratios, which you will learn in chapter 7.1, to determine quantities of reactants and products in a reaction. Mole ratios are directly related to a balanced chemical equation. So long story short, if you notice, or if you know that it's going to be a stoichiometric calculation, stoichiometric question, you must identify a chemical reaction and balance it. Just balance it right away before anything else, okay? Also, you will find that as we get through these questions, format is going to be so important. If you have poor formatting in how you do this question, you're going to get confused along the way. So I highly recommend you at least adopt some, if not all, of the ways I go about solving stoichiometric calculations. Okay, so what do you get from all this? When you get a stoichiometric calculation, get your chemical equation, balance it right away. Okay, and away we go. There are two questions I'm going to do with you. Number one, I'm going to give you a certain amount in the beginning. I'm going to give you a certain mass of reactant, and you are going to use mole ratios and do a stoichiometric calculation to figure out how much of a product you are going to get. And then I'm going to reverse it. I'm going to give you how much was produced, and you are going to reverse engineer, use mole ratios to figure out how much we started with. You'll get a better picture once we follow. Here's our first question. I am going to have aluminum, and it's going to sit out in the air, which allows the metal to oxidize, creating an oxide. There it is. And the question is this. Okay. Bear with me here. First video, it's going to be a little choppy. I'm sure it's going to be a little bit, it'll be smoother as we go along, okay, as the weeks progress. If I have 108 grams of aluminum and let it sit in the air, what mass of aluminum oxide will be produced? Okay. As simple as that. And now please note that letting it sit outside in the air is a direct assumption that, let's use a different color. It's basically a clear assumption that unlimited amount of oxygen molecules. In other words, I'm only going to look at the aluminum. Okay, here it is. Stoichiometry. What did we say before? We need to balance that chemical equation. So go ahead and do that. That's going to be a 2, that's a 3, and that is going to be a 4. Okay? Step 1 in doing a stoichiometry calculation. If you were with me before the March break, if you came to the last lessons, then you would find this little chart familiar. Every time you do a stoichiometry calculation, I highly recommend you create this little chart right under it. It's about formatting. It really organizes your notes. Okay? Why do I have these 3 things? Well, if you remember, the equation for moles is mass over molar mass. So I have mass on top of molar mass, and if I divide these two, I get my answer number of moles. It's just nice. And also sets us up nicely for future stuff. What does the question give you? If I have 108 grams of aluminum, so I have 108 grams of aluminum, then what is the mass of aluminum oxide I'm going to create? You may be tempted to go from the 108 directly to the X, but you can't. Right here, mass alone is insufficient. In fact, the only way we can go from one part of a chemical equation to another is by going through moles. So this is your process. You take your mass, you're going to calculate the number of moles, and using mole ratios, you are going to figure out how many moles of another product or another compound is going to be present, and then use that number of moles and figure out some other information that you want. These 3 arrows are what you're going to calculate. It's a 3-step process. I'm going to erase it. I'll just keep that. Okay, so let's do it. I'm going to use a different color just for you. This is the first section. I have 108 grams of aluminum. And my goal is to find the number of moles of aluminum. What do I need? Of course, I'll need molar mass, and you should know that from your prior practice before the break. Aluminum's molar mass is 26.98 grams per mole. So let's do it. Number of moles is equal to mass over molar mass, which is 108 divided by 26.98, which is going to be, bust out my calculator, 108 divided by 26.98, 4.002965, so on and so forth. Sig figs, the question gave me 3. There it is, 4 moles. Okay, so I have 4 moles. How many moles of aluminum oxide is going to be produced? Well, you may be able to use a little bit of your logic here, but this is where 7.1 comes in. The only way we can actually figure out how many moles is produced is directly relating it to a balanced chemical equation. If I have 4 molecules of aluminum, I'm going to produce 2 molecules of aluminum oxide. If I have 400, I'll produce 200. If I have 4 million, I'll produce 2 million. If I have 4 moles, I should produce 2 moles. But your logic is not going to always be helpful. So let's actually do the grunt work, okay? Let's do all the work so that you know exactly what's going on. You are going to do a mole ratio. You're going to compare the number of moles of aluminum to the number of moles of aluminum oxide. Create a mole ratio. It's a ratio. It's a fraction. 4 to 2. With me? 4 to 2. Well, okay. Well, from here, if I had 4.00 moles, what would the number of moles be? You have two fractions, cross multiply. 2 times 4 is 8.00 equals 4x. X is going to equal 2.00. Okay, so let's fill it in using a different color. 2.00 moles right there. Great. Now that we have the number of moles of aluminum oxide, what is the mass of aluminum oxide? I think you can guess. I need the molar mass of aluminum oxide, which is 2 times 26.98 plus 3 times oxygen, which is, bear with me here, 2 times plus 2 times 26.98 plus 3 times 16, 101.96 grams per mole. Mass is moles times molar mass. It is this initial equation rearranged. 2.00 multiplied by 101.96 grams per mole. That is equal to 203.92 grams. Sig figs. Therefore, the mass of aluminum oxide is going to be 204 grams. X is equal to 204 grams. It's tough, right? But you'll get used to it. If you have the number of grams, you convert it to the number of moles. That's the first calculation right here. Then you use mole ratio to move to another part of the equation, and that's the calculation right here, mole ratios. And then you will follow this arrow. You will use the number of moles to calculate the mass of whatever it is you need. Okay, and that's this calculation right here. Hope that helped. Now I'm going to take this and ask in reverse. I have a second question for you. So if this is question 1, I have a second question for you. Okay, so pause the video right here. If you want to copy anything down or you want to try it yourself, go for it. Okay, I'm going to move on with the second question now, assuming that you have stopped the video and started again. The second question is this. Okay, great. If 204 grams of aluminum oxide was produced, how many grams of oxygen gas was used up? Here's my second question. Some of you might be creative and use the conservation of mass to do that. I'm going to purposely pretend I don't know how to use a conservation of mass, and I'm going to use mole ratios once again. Okay, so the same equation is involved, but this time I'm going to erase all of this because I don't need any of that. And I'm going to erase all of this because I need some space to do some work. Okay. I accidentally drew that out. If, just as I predicted here, or just as I calculated in the previous question, if I have 204 grams of aluminum oxide, how many grams of oxygen was produced? Can you guess what I'm supposed to do? I can't go directly as I said before, okay? So if you have the number of products and you want to find out how many reactants there are, you're going to have to find the number of moles, use mole ratios to find the number of moles of the whatever molecule or compound we're interested in, and then go back and calculate the mass. Okay, so let's do that. First step, I'm going to go ahead and calculate the number of moles. If my mass of aluminum dioxide was 204 grams, the molar mass from my previous question is 101.96 grams per mole. What is the number of moles? Well, mass over molar mass, 204 divided by 101.96, and that is going to equal, well, I guess there was no point in me calculating. That was embarrassing. I already know it's going to be 2 moles. Okay, now let's transfer over and find out how many moles of oxygen was used using mole ratios. The number of moles of aluminum dioxide to the number of moles of oxygen is going to be 2 to 3. What if I had 2.00 moles and I'm looking for the number of moles of oxygen? Well, again, you could use common sense, but I'm going to pretend I don't know common sense. I am going to cross multiply. This is going to be 6.00 equals 2x. X is equal to 3.00. The number of moles of oxygen that were used in this reaction is right there, 3.00 moles. That's the last step. Let us go ahead and calculate how many grams, oh my goodness, how many grams of oxygen were used? Number of moles of oxygen is 3.00 moles. The molar mass of oxygen gas is going to be 2 times oxygen, so that's 32 grams per mole. That means the mass, which is the mole equation rearranged, 3.00 multiplied by 32. That's going to be 96.0 grams. The number of oxygen molecules, number of moles of oxygen is going to be, number of grams. So 96.0 grams of oxygen is used to oxidize aluminum. This exercise or this example sort of summarizes all that you need to do for chapter 7.1 and 7.2. It talks about how you need to use mole ratios to go from one side to another. And it also talks about how you may be given mass instead of the number of moles, which means there's an extra couple of steps you need to do. Please practice. I believe I already assigned this in the previous weeks, just as busy work, but this time it's official. I would like you to, as your homework, try page 320, numbers 1 to 4, 6, 7, and 9. Page 325, numbers 2 to 10. Okay, as per assigned. If you have any questions, some people have already been emailing me, which is great. If you have any questions, please ask away. It's going to be very helpful. And you definitely need to know this. This is the foundation, the cornerstone of grade 11, grade 12, anything in your chemistry future. Okay, so please practice this and do not move on before you are comfortable with it. Good luck, and I guess I'll see you next week.